Hello and welcome to this reclass of Session 5. This will be a very short demonstration of a couple of things. I must apologize for the sound quality. I'm using the built-in microphone on my laptop. In this class, what we covered was how the encapsulated calculator should have been done, and that's taken with a grain of salt because there are other ways you could do it. Introduction to the CamelCase set of, well, not really rules, but it's a convention, and we will be following it in class. And an introduction to using while loops. Now, the loops that you used previously in basic mode, novice mode, or whatever mode it's called in Raptor, were not while loops. They were kind of the opposite. They were for loops. Well, no, not really, but it's a different kind of loop, what we're using now. So if you ever used one before, this is different. If you didn't use one, well, I guess you don't have to relearn anything. Okay. First, we'll go over how the calculator should have been done. Alright, so anytime we do an object-oriented program, the first thing we do is create our class. Alright, and then we go into the members of the class. We said we needed 2 fields, and we need 1 constructor. Now, the assignment called for 4 methods. I'm just going to do 2 for time limitations here. We'll do addition and subtraction. The fields will obviously be the numbers that we are going to add together or subtract. If we're following the paradigm of encapsulation, we have to use parameters . Now, I'm naming these num1, num2, num1, and num2 for a very specific reason, which we'll see shortly. I'm copying the parameters from one and just pasting them into the other method. Alright, the functionality is pretty simple. The only thing that we need to do is we're going to take our field and set it equal to the number that's passed in as a parameter. Same thing here. Just say we're setting the field equal to the parameter. Okay, that's finished. Simply do an output. I'm going to copy this, and we'll do num1 plus this dot num1 plus this dot num2. Subtraction is more of the same, except we say this dot num1 minus this dot num2. Inside of main, the first thing we need to do is ask the user if they would like to do a calculation. store their answer in a variable, a local variable called user choice. After which we will now create a check to see if user choice is equal to yes, but we're not actually going to do that because the loop will come in a few minutes. I'm just going to leave it there for now. Now I'm going to make an input saying which calculation the person's going to perform, or the program actually is going to perform, but what the person or the user actually wants. I will store this into a variable, a local variable called calculation choice. Now, the way I advise to do it is to limit the calculation or the output. Inside of the output, you actually, the prompt, you limit what the user is expected to enter. Now, the way that I would do it is inside of here you say press 1 for addition, 2 for subtraction, etc., etc. Alright. Another way you can do it is say Alright, so I'm making a string. I'm saying I want you to enter a string, add or sub, depending on if you want addition or subtraction. So here I would compare calculation choice. Is it equal to add? If that's true, I would do my addition over here. If it's not true, then I would do a calculation choice compare with sub. And if that's true, do a subtraction. For each of these, I need to create a calculator. You could do that up here if you wanted to. It doesn't have to be inside of here. To me, it makes more sense that way. I'm going to prompt the user to enter some information. What is the first number? What is the second number? After I've collected this information, I can now make a call to the addition method on the calculator instance. The information that it's expecting which it refers to as num1 and num2. This is the name of the parameters. Here I can just use the local variables that I created, number 1 and number 2. I just do a quick copy paste. Make a couple changes. All right. Should function. Checking the output, it works correctly. So, this. Inside of these selections, the reason that I would suggest saying enter 1 for add or 2 for subtraction is, what if you have a user that enters their information like this? Are they entering add? Yes. Is this going to go to add? No, because lowercase characters are different than uppercase characters. So this will return no. It will return false. So that's why I have you to limit the input of the user. Now, if you're dead set on doing this, you have to compensate for the user entering different characters but meaning the same thing. This character, the vertical line, means or in programming. So I can say, well, what if calculation choice is equal to lowercase add? Or what if calculation choice equals a capital A and 2 lowercase d's? This kind of programming will compensate for that. It will take into account, okay, what if this is true? If that's true, okay, run the yes branch. Or, well, okay, well, what if this is true? Okay, if that's true, then run the yes branch as well, etc., or a ditto with this one. Now, if you want to check and make sure 2 things are true, 2 things have to be true in order for this actually to run, you would just use ampersands. The convention is, in Raptor, I want you to use double relational operators, or these little symbols, equal signs, ampersands, or the vertical line, if you are doing a comparison. Now, it's a convention for us, but it's a rule in programming, real programming. So you might as well get used to the idea now. Alright? So well, I guess it actually is a rule inside of Raptor. You have to use 2. Alright. So that's how the calculator. Now, obviously, the next part would be, okay, you put the same thing over here for multiplication and division. Alright, and for no, you would say, enter something, enter the correct number. Okay. Introduction to CamelCase. Alright, throughout your time programming, you're going to find there are lots and lots of rules. We've seen many different rules, but there are things also called conventions. Alright, syntax is an idea, and we saw that whenever you tried to enter int num1 as your parameter, it worked fine. But if you entered int num1 without a space, you had an error. This is a rule that cannot be broken. Same thing for you were trying to make a new calculator, but you had calculator spelled wrong inside of the class. You can't make a class if it's spelled wrong. Well, you can actually still make the class, but whenever you try to call the constructor of the class, you have to spell it wrong there too. So spelling is important, and that is another part of syntax. But another part of syntax is conventions, like I just mentioned. Some errors are easily avoided, like the spelling mistakes. And I just gave this example. If you try to make an instance of class Bobo, but you have no class Bobo, but you do have a class Bob, you'll get an error, obviously. But what if you're trying to access a method of a class, but the class actually has a field of the same name? Or what if you have a parameter of a method, but the class of the method still also has a field of the same name? So if we look at this program that I made, we can see this. We can see that addition and subtraction both have parameters named num1 and num2, but also has fields named num1 and num2. Now, until you're used to programming, this might look a little bit confusing. Okay, well, which one is num1? Alright, so in order to both make things easier for you reading the code, and what if you make a program and you get halfway through it and your teammate has to finish it later? He gets into your programs and starts looking at your variable names and can't figure out if this is a field, or you're trying to access a variable, if it's a local variable, or if it's a parameter, if this is a method call, or a, So to separate all of these different variables and instances that you can create, we use a commonly used convention. That's pretty much what I just said. Okay, now we could just name them certain names, but some names are logical to actually have, like I just demonstrated. Is it logical to assume that a parameter for the first number entered is a good name for it would be num1? Sure. What about the second number to be num2? Yeah, that's logical. Is it logical for the fields to be the same way? Yes, of course. And some programmers program that way. They keep things the same names every time. So anytime they come back and look at their code, they'll look at their own programming convention and know exactly what things are. But for novice programmers and for well, really generally anyone, especially if you're working in a large group of people, everyone uses a common language, so to speak. And for a lot of people, that language, or that way of naming variables, methods, and classes is called CamelCase. Alright. Inside of Word, I'm going to show you exactly what the expectations are. Alright, so switching into Word. This is the how well. This is how CamelCase works. Okay, we don't use spaces ever. You can use underscores and numbers and some other special characters, but preferably the underscores are reserved only for parameters or local variables. You don't have to use them for local variables, but they are preferred. Okay, so for a field, the rule is going to be, and a rule is, lowercase, uppercase. Alright, so the first word is lowercase, and the second word starts with a capital letter, and every subsequent word has a capital letter. So, for example, last name will have a lowercase letter for last, and a capital N for name. Last name and first name, if this was a field, it would start with a lowercase l, and every subsequent word starts with a capital. Okay, so that's fields. Classes and methods. Upper, upper. So, essentially we are saying that all words have a capital letter at the beginning. So, for a class called calculator, since it's only one word, it's still, the first word has a capital. Okay. What if we do calculator scientific? Every word is capitalized. Calculator scientific 1. Everything's capitalized as far as the beginning or the first word or first letter of every word. This applies to methods and classes. So if you make a method, addition, go, this method will have capitals for each word. Parameters are just like fields in that they have a lowercase letter, but that's where the similarities end. You have underscore, lower, lower. So for a parameter num1, it will look like this. Underscore is shift and the question mark button. If you were to spell out the 1, it would be like this. Generally, you don't want to make parameters more than 1 or 2 words, because it really has no purpose of being any more than 1 or 2 words. But some people do it. Alright, finally, the last thing is statics, or singletons. This we have not gotten to yet, and I can't guarantee that we will, but let's assume that we will. Alright, so with this one, everything is caps. So if you make a static or a singleton called my calculator, it would be and that's it. We haven't used this yet, but the calculator, the encapsulated calculator, does fit into a singleton design pattern. You don't know what that means yet. You can look it up if you want to. You don't have to. We will get to it when we get to it, if we get to it. Alright, so we know now that Bob would be a method or constructor, so that we could actually look at this word with the, well, it's really a method, and know that it's either a class or a method. We can look at the word Bob next and know that with a lowercase letter it's a field. The next one, we can look at that and know that that is some type of parameter. Okay? So that's how we will differentiate from them from now on. Okay, now the next part. Introduction to while loops. Alright, so looking at this program started previously, let's say we want to take advantage of this user choice variable now. And we want to look at this user choice, and if the person wants to do another calculation, we can just do this entire thing again. First, I'll add the loop. Now, how loops work are they're just like selections. But instead of going to two adjacent branches, the yes branch circles back around to the top. So, if something is true, it will repeat. And so we can assume that this is going to be the user choice variable. We're going to look at it. And if it's yes, again, at the end of the loop, well, actually it would be the beginning, we exit the loop and continue on with the program. It makes more sense in practice than it does in explanation, so let me show you how it's done. Alright, so the first thing we do now is ask if the person would like to do a calculation. Now we're going to look at user choice. If user choice is in fact equal to yes or yes or okay, so if user choice is equal to this way or this way or this way, we will run the loop. If it is not, then we simply exit the loop. Alright, so let's test it. Would you like to do a calculation? Yes. So it is true. Now it goes down into the loop. If we test it again and say no, it exits the loop before it even starts. Now, so at the end of the loop, we can add another input. And we'll just simply say, would you like to perform another calculation? Enter yes or no. Alright, and that's it. That's how a loop works. We always have to work towards this eventually being not true. Otherwise, you get what's known as an infinite loop. You will never be able to change this to equal this, or this, or this. Therefore, the loop will never exit. So you must do something within your code to eventually make this variable equal no, or you have to do something inside of your code here to make this selection statement eventually return no. Okay? Alright, so that's it for this reclass. We saw how the encapsulated calculator should have been done, or a way it could have been done. We have an introduction to CamelCase, the convention that we will be using inside of the class. And yes, I will be counting off for this. And an introduction to how to use the loop function in OOP, which is known as a while, well, the OOP version of Raptor. And this loop is called a while loop. And it's called that, you say you perform the loop while this is true. So as long as this is true, keep looping. And as soon as it's not true, you exit the loop. Alright, so if you missed anything in class, I hope this covers it for you. And if you didn't understand it, I hope you understand it now. Thank you and have a great day.